Given the title of this video, if you're here because you're expecting me to create something like this, then to be honest, you're going to be disappointed. And what I strongly suggest is you don't bother with the rest of the video, just don't watch it. And if you feel really clickbaited and offended, well, leave a dislike. What I'm going to do is make a generator with principles we've discussed before on this thing. It's the xtool P2. And I'm going to make it out of this stuff, which is clear acrylic. And I've called it the crystal generator because I want to be crystal clear both in being able to see through it, how it's made, and why it's made. And these are important things. Why is because every time you make something, you make a decision about how you're going to make it, and that's not going to be relevant to every single person. So being clear about why you made it that way means that people can make changes, and that's the whole point. You don't just copy something, you make something and make the changes that are important to you. We're going to make it on this thing, the xtool P2, because it's a good tool. It's clean, it's accurate, it's easy to reproduce things, but it's a tool to do a job. The generator itself is flat plate design. You could make it from wood if you want, you can make it from metal if you want, you could 3D print it if you want, you can cut it on a laser cutter if you want. This is just a tool. As I say, it's a good tool, but it's a tool. I happen to like it because it fits my situation. It's compact, it can do a huge range of tasks. For me, that's awesome. If you happen to have a different tool set, fantastic, use those. Don't get into that framework of, oh, it's a laser video. It's not. It's a how to build a generator video using this tool. You can use other tools. So I turned to Tinkercad and drew this up, and there are 4 colours. The cream is meant to be cut from 10mm acrylic, the blue is 2mm acrylic, the orange is 5mm acrylic, and the red is meant to be 3D printed. And that's just an example of where the 3D printer would be better than the laser cutter in this example. So that's what I'm going to do because I have both machines. But you could laser cut them by making them in slices and then just gluing them all together again. Equally, I'm going to put these files onto Thingiverse as STL files. So if you want to 3D print the whole thing, knock yourself out. If you want to laser cut, export the STL from Thingiverse, import it into Tinkercad and re-export it as SVG files, and you're going to be good to go. If you want to do it in another material like metal or wood, then just print them flat on a piece of paper, glue them to your wood and saw around them. There is no limit here. What happens is you limit yourself. If you're looking for ideas to 3D print a laser cut, well, look in woodworking or metalworking, or if you're a laser cutter, 3D printing, and vice versa. If you're a 3D printer, have a look at some really great woodworking bits and pieces and see how you can turn those into a 3D print. Don't let your own preconceptions just push you down one path. Be broader in your view and you'd be amazed what you can come up with. Okay, let's get some laser cutting done. Once you've printed them off, cut them out, sawed them from wood, whatever you choose to do, you're going to have a whole pile of parts. These ones have cut from 10mm acrylic because the xtool P2 will cut 10mm acrylic. If your laser won't, well, cut them in 5mm and slap them together, you'll have 10mm. You're going to need some other things too, of course. You're going to need some of these things. These are bearings. Now, I choose skater bearings quite simply because they're all over the place. They're always the same, 22mm by 8mm by 7mm. You can find them in abandoned skates if you want to repurpose. You can find them on Amazon. You can find them in local shops. They're easy to get hold of. They're mass-produced. They're cheap. And they even make a ceramic version, which is really cool and spins for ages. So I use those kind of bearings for those reasons. If you're scavenging bearings and they're various sizes, well, change the hole. You don't need to change the position, but you can change the hole size easily enough to fit whatever bearing you happen to have scavenged. I tend to use these. These are the magnets, and they're 15mm by 4.5mm because that's what was available for no other reason. If you have different magnets, again, you've scavenged them, fine. Change the hole. Whatever it is to get them to fit, it really doesn't matter. People often ask me, about the wire that I've been using. And to be brutally honest, it's almost unimportant. As long as it's relatively thin, it doesn't really matter. If you're using something as thick as your arm, you're going to have a problem on this model size. But anything sensible, it really doesn't matter. It doesn't matter if it's a fresh coil, it doesn't matter if it's a found coil, it doesn't matter if you've scavenged it from somewhere. It just doesn't matter, which is why I don't understand why people ask. There's a whole host of ways of doing this, and the adaptability are about you. This is just a guide on how to put things together. You can put things together from whatever you've got or what your favourite materials are. It just doesn't matter. Now, if you're going to use acrylic, then you're going to need some glues. This is my standard go-to. It's super glue. I'm going to use that for gluing some of the plastic parts. Unfortunately, on something that's clear, super glue will leave a white residue, so I've chosen to use this stuff, which is in fact a solvent. It dissolves the acrylic, and then when it dries, it sets the acrylic as a bond, and it's a really tough bond and great for clear acrylic. To make it, take this thing and then this donut, stick that in there and then stick those in there. If you're going to 3D print this, you could merge this in Tinkercad and print it as one piece. The only reason I've chosen this circular design is because if you're cutting it from wood, then a bit of dowel 15mm with 14mm lengths cut off, and there are 12 of them, will do exactly the same job. If you fancy cutting out or making a pretty teardrop design, knock yourself out. Teardrops will do just as well, because we're going to use a serpentine coil. Now, I've said very often that the only reason I use a serpentine coil is because I think it's easy to make. If you prefer standard coils, well, just wind standard coils. The only criteria is there needs to be 12 of them, because we're going to be putting 12 magnets in the magnet ring, and the legs on a serpentine have to equal the number of magnets. If you're doing standard coils, you could put 6 in there if you wanted, or 4 in there if you wanted, because it doesn't matter so much with standard wound coils, but it does matter with a serpentine coil. Anyway, let's glue those in place. When they've had a chance to dry, take this bit, and you'll notice there's a scrap bit of 2mm there. Lay it over, position it and glue it in place. Incidentally, you'll notice I'm working on a bit of tile. I'm working on this bit of tile because the surface is glass and it's next to impossible to glue anything to it. Anyway, let's use this stuff and glue these two bits together. Now, I have done a ton of videos on how to make a serpentine coil, including video 1800, video 1859 and video 1929, if you want to check those out. But basically, it's just one big single coil that you wrap with tape and bend into this squiggly starry shape. The coil itself has got 250 turns on it, and it's made of 0.1mm wire, and you jam it in to the housing that you've just made. And there's actually one thing that's important, and that is that leg is straight, because the magnet will pass over the straight and generates at the straight bit. This bit here will generate nothing. And this is one of the downfalls of serpentine coils. They are easy to make, they do a really good job, but they're expensive in copper, because this bit and this bit are basically wasted. Now, clearly I could get much more wire in there. I've just done this because I know 250 turns is going to give me a good result. Fantastic. I could jam more in there if I wanted, and the more the merrier, because it won't really affect the efficiency. What it affects is the power density. It'll be heavier because there's more copper. It'll be more expensive because there's more copper that you're not using. But the copper that you're using is as effective as any other coil shape, and it brings with it benefits. Anyway, we jam that in there, take this section here, that glues on there holding everything in place, and then we put a couple of bearings right in the centre. And that's it, that's the coil finished. Now let's have a look at the magnet holders. To make the magnet carriers, we use this bit here with a backing plate, that bit there. Line them up, and in order to line them up, stick a bolt through it, and then glue that to the bottom piece. Again, if you're doing 3D printing, you could merge this as one piece. We're doing it this way, so we now need to glue it. And when that's done, put a spot of super glue in the bottom of each one, take your magnets as a bar, push it in, slide it off, do the second one, and they'll all be pointing the same direction. Then turn it round, slide that one in, and you'll get north, south, north, south, north, south. Then when you've done that, do the same with the other end. Now take your base plate, which is this bit here, and you'll notice it's got some slots cut in it. It's got thicker slots and thinner slots right there. You need one of the side arms, it doesn't matter which one it is or even which way around it goes, and you glue it on there, lining it up with the inside of the thicker slot so it's smooth from the slot to the side arm, and obviously some distance in here. You'll notice the side arm actually has these here. These take bearings, so you put a bearing in there and a bearing in there. Then take the big gear with the small hole in it, and then this bit here, this bit's actually going to be the handle. We need to glue those on top, so same trick, stick a bolt through it to line it up, and then put some glue on once you've lined up those little bits there. So take some 8mm acrylic bar and cut off 43mm, so you've got that, and that goes into that. I've put a red plug in this one so we can recognise it, but it shouldn't really have that red plug. Push this through there so it sticks out the other side 10mm. Like that. When you've done that, stick one of these spacers on it and then put it through that bearing. Add another spacer on there and then glue the small cog on. Now you're going to need a bit 74mm long and you glue it in there. Add 2 spacers. And when it's dry, it goes through that top one there and engages with the small cog. So it's like that. Now we need 115mm of 8mm rod, and it goes in there, and then the handle will slot on there. To finish the handle, this 5mm washer goes on, but not all the way down. You don't want to catch the handle, you just want to hold it in place, and then we glue it. So we should have one more small gear left, which is right there. Glue it onto a bit of 8mm acrylic and feed it into its bearing. Here, because these are set too close, that bearing is 8mm by 12mm by 3mm, and there's 2 of them in there. And now we're ready to feed this next support arm facing that direction onto these. Okay, and that finishes off the gear section. So we rotate that handle through the gears, it steps it up to rotate that shaft at about 2000 RPM, and that shaft is the one that carries the magnets. So we slide the first set of magnets on and glue it, and then we slide the coil on. There's 2 last things I want to point out. The first one is this. So there are 4 spacers, 2 at the top, 2 at the bottom, and they keep everything parallel and the right distance apart. And the second thing are these spacers here, which are along all the axles, keeping all the discs apart. Now what we need to do is add our second magnet disc, and it goes on the axle like that. As we move that close together, if that's a north, it will automatically attract the south, creating a magnetic field that runs at 90 degrees to the wire. And there it is finished. Now there's a couple of interesting things about it. The first thing is the coil, the serpentine core, which I love for the reasons I've explained. And the second thing is the magnet arrangement. It's called axial flux. When you've got these 2 flat magnets, north and south, opposite each other, then the field is all bent across between the 2 magnets, focusing it pretty well across the wires and giving it a 90-degree cut across the wires, which is about the best you can get. It also means that you actually don't need cores with this. It performs really well as what's called a coreless generator, which is great if you're going to make it out of alternative materials, that is, materials that aren't metal. So in terms of a design for home building, I think this is an awesome design. But of course, let's get it to do something. We're going to light, and we're going to see if we can get some measurements out of it. So there we go, a working generator, and it took me a day, less than a day actually, to do this, and that includes doing the video and doing the drawing. So I guess if you were to cut this out and build it yourself, you're talking about 2 or 3 hours work, something like that. Now you might have heard a clacking noise. The clacking noise means something's moving and we're losing power to friction. These axles are acrylic, they're a bit wobbly. If you replace those axles with 8mm steel bar, you'd cure that clacking noise and get even more out of it, no problem at all. And what I want you to do is see how easy a generator can be. Yes, they can be complicated, but with basic principles, they can also be super easy. If you wanted to improve this, of course, you're looking at things like the distance of these magnet rings from the coil. Again, with these are set quite far apart because I know the acrylic's a bit wobbly. But with steel, you can get those much closer together and your output is going to go up. I used this serpentine coil and only one of them and hardly any of it. So you could put 3 coils in there and get a 3-phase. You could put a different coil design in, your favourite coil design, whatever that is. It's a jumping off point more than anything for you to experiment with, and there's tons of ways that are simple to improve its performance. Now, in terms of performance, well, we got 30 volts open circuit. It's probably about 20 volts because this turn-on voltage for that lamp's 20 volts, and we got maybe half an amp or so. So round about 15 watts is what was being produced, and that's no real surprise. The voltage is produced because of the magnets, the speed, and the coils. The ampage is produced because of the load. This needs half an amp to turn on at 20 volts. That's what this was producing. Now, the maximum of this is only ever going to be 60 watts, actually a bit less than 60 watts. And the reason for that is that's the power in I can put from my arm. I've got about 60 watts that I can put into that. We'll get losses and we'll get less than 60 watts out if we do the max on it. Now, this machine may or may not be able to cope with that kind of turning force. So we need something to produce greater turning force. We need to build a robust machine. But the essence of the machine is identical. Now, I chose hand just to demonstrate it because we've made this kind of generator with wind turbines, well, all over the channel. It's a favourite generator of mine because this design of axial flux means it performs really well as a coreless generator, meaning you can make it from tons of things. The whole point of this video is for you not to get hung up on the laser cutter. The laser cutter means that I can do that really quickly, and it's an awesome job because it helps with that. But it can be made from a whole range of materials, as I've pointed out. A whole range of tools, as I've pointed out. Don't get hung up on the laser cutter. Get hung up on the generator design, being able to see clearly, crystal clearly, what's going on. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.